So let's go ahead and try one more example, but this time let's say we know our current total, but we don't know our voltage. So to solve for our voltage, we of course need current total and resistance, because voltage is current multiplied by resistance. And we know our current. Our current total is 125 milliamps. But we do not know our resistance total. So the first thing we have to find is, of course, our resistance total. And since this is a parallel circuit, we'll go ahead and use our inverse resistance equation. So we'll say 1 over resistance total equals 1 over resistor 1 plus 1 over resistor 2 plus 1 over resistor 3. And we'll stop there. Since there aren't more than 3 resistors, we would just have 3 in the equation. And of course, we know what each of these numbers are. We know resistor 1 is just 1200 ohms. We know resistor 2, so 1 over resistor 2 is 1 over 270 ohms. And we know resistor 3 is 580, so it's 1 over 580. And so to solve for this, since these numbers are so big, we would just use our handy-dandy calculator. And normally, like in our previous videos, you might remember we use this numerator over denominator button in our calculator, where we put 1 over our bottom number, which is 1200 in this case. Then we left it and hit the plus button. And we hit this button again, and so on and so forth. But what if you weren't given this numerator over denominator button? What if you had a different calculator? How would you type it in then? Well, it's actually pretty simple. What we would do is we would type each fraction in parentheses. So I would open a parentheses and say 1 divided by 1200. And then I'd close it, and then I would say plus. And then for the next fraction, I would do the exact same thing, 1 over 270. And then I'd close that, and then I'd say one more time plus, because again, there's a plus sign. And I'd open my parentheses, and for the third fraction, I would just type in 1 divided by 580 and close that parentheses. And so in this, or a calculator without that button, this is how I type it in. And I would get this very small number, this 0.006261, so 0.006261, and then yada, yada, yada. And then we would just take the inverse of that number. But again, what if you don't have this inverse button nicely placed in your calculator? How would you figure it? Well, all an inverse is taking a number and putting 1 on top of it, basically. You're just flipping the fraction. So what I'm going to do is flip this fraction by putting 1 on top of the other number. So what I'll do is actually type it in. 1.0062611175. And we get a total resistance of 159.7. And so all I did there was essentially do the same thing that as if I just hit the inverse button. This is how you take the inverse in a calculator without an inverse button. You just put 1 on top of it. So we can go ahead and write that out. We can say resistance total equals 159.7 ohms. And if you take a second to think about it, that makes sense. Since this is a parallel circuit, we should be improving the current, which means the total resistance should be smaller than each individual resistor. And if any time you get a resistance total in a parallel circuit where the resistance is bigger than any of your resistors, any of them at all, even the smallest one, you know your resistance total has to be wrong. That being said, you also should not get some number that's this small. That means you didn't do your final step, taking the inverse. But with all that being said, we can now solve for our voltage, because our voltage formula hasn't changed. It's current total times resistance total. And we now know both of these numbers. Current total is 125 milliamps, which if we take the time to convert that to regular amps, which we need to do to be able to use it in math, we'd move the decimal place to here. And what we get is current total is equal to 0.125 amps. And so this is the number we would actually use in our math equations, or else we'll get a very, very wrong answer. So we'll say 0.125 amps, and we're going to multiply that by our resistance total that we just figured out, which is 159.7. And if we type this into our handy-dandy calculator, what do we get? Well, let's see. What's 0.125 multiplied by 159.7? And we get 19.9625. Let's just go ahead and say that this is a 20-volt battery. And if you're asking yourselves, what about current 1, and what about current 2, and what about current 3? Well, the question only asked for the voltage, so you could solve for those, but there's really no reason to. So we can just stop here at finding the voltage.